Well, gentlemen, we're here to talk about RO number 83 and RO number 84. I do believe. I believe this is 83, this is 84. Another day, another Texas Star. This is a Sweet 16. This is a Texas Star. Supposed to be a 500, and it is. I cannot wait to see what we find inside of here, and I don't think we're going to have to spend a lot of time inside of this. But here I think we're going to have to spend a little bit of time. So let's open them up. Let's take a look. Well, gentlemen, we're here to talk about RO number 83 and RO number 84. I do believe. I believe this is 83, this is 84. Another day, another Texas Star. This is a Sweet 16. This is a Texas Star. Supposed to be a 500, and it is. I cannot wait to see what we find inside of here, and I don't think we're going to have to spend a lot of time inside of this. But here I think we're going to have to spend a little bit of time. So let's open them up. Let's take a look. After seeing how long these screws are, I think this washer is pretty important, because if we didn't have that, I think it would short against the board. We're at the tail end, man. I just got a couple more ROs to go for 2023, and then I'll be able to start into the 20 that I took on for 2024. So, oh, it's got Toshiba's in it. Oh, it's been burned up once or twice. Yeah, it's gonna need a power wire upgrade. It doesn't look so rough in here. It doesn't look bad at all. It's gonna need a new meter. We'll see if we can salvage the faceplate. Now, on top of this same customer ordered from our friend at Beard Amplifiers a Beard fan kit. Actually ordered 2 of them, and he had them drop shipped here. So there's the fan kits. Probably going to want to replace this capacitor. It's a little, well, it's been a little hot. So, I mean, that's no big deal. We got those. This doesn't look that bad in there, really. It doesn't. I mean, we can see where the combiner has been chooched a couple times, but that'll wash all away. The duct tape holding the face on, that's priceless. But we'll pull the face off, and we'll see how well we can get the duct tape jizz to clean off and see what's underneath this. And maybe we can go back and we can glue this on. It's probably gonna need some new LEDs, but I mean, looks like somebody's already tried this at some point or another. So, whew, look at that. It's our sideband delay capacitor. Wow, this thing has gotten hot. Okay, let's make it better. I'm gonna have to spend some time with this amplifier later tonight, because this box, this Texas Star 500 is running better than any other Texas Star 500 I've had come through here. So I'm gonna have to spend a little bit of time looking at this. Before we get on to showing you the testing, let's show you what we did. We changed out the 222 picofarad capacitor here, went to a 270. That dropped the input tune way down to nothing. Did the power wire upgrade, put a new meter on the front, put all LEDs in it, did the power wire upgrade, got it all, and dude, we got the fan kit ready to rock for this amp. This amp needs a fan kit. I'm here to tell you what. Okay, so let's go over here. So we've got the steaming coax digital meter with a 1 kW slug out of this hole. We got to put over here, and we got it reading an average. So amp is off. 1 1 1 1 1 1 1 1 1 1 1. Okay, so we're looking at About 25 watts going in. Let's turn the amp on. Hello. Hello. About 750 watts peak. Hello. About 375 watts average. Hello. A little off. Go back over here. You know what? I'm not gonna mess with this right now. Keeps telling me don't worry about this. Let's go over here. Hello. 300, 320 watts average. Let's go look at the input tune real quick. Remember we're getting like a full watt in reflex? Hello. Hello. Way better input tune. Way better input tune. So we're seeing nearly 800 watts peak. I'm gonna have to spend some, like I said, some time tonight making some notes on the capacitance values here and turns ratios and everything, because this thing is acting like nothing I've ever seen before. Let's turn the amp off. Now we're on the bench derail striker 955. This is our drive. Hello. 120 we've all come to know and love. Hello. Hello. Over roughly 500 bird and 1,000 peak. Out of a Texas Star 500, y'all. Hello. 1 2 1 2. 1 1 1 1 1 1 1. Hello, 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 hello. Now, we are running into the problem that we are about overdriving this amplifier. Hello, 1 1 1 1 1 1 1 1 1 1 1 1 1. Hello. We can see it almost go up to 2 bars on this meter. Input and output tune's perfect. Pass-through tune is perfect. Oh, yeah, I gotta change radios. I have to demonstrate this on video, you guys, so let's backtrack here a hot minute. I totally forgot to do one thing. This amp is a rocket ship, dude. Like I said, I'm gonna spend some time with it tonight. We're gonna make us some notes, and then in a box here I've got several Texas Star 500s. I'm gonna see if I can emulate this, because this is somebody's been in here before. They've changed quite a few different parts, and you can tell that the soldering iron's been in here. Okay, so back on the bench 2950. Preamp is working. I spent so much time with this switch, but what that is our delay. Delay is working perfect. Man. There we go. I'm gonna have to glue that switch in there, glue that in there. But the dial-a-watt, that's the main thing. Let's go look at the dial-a-watt. Throw up a little bit of a dead key, but 3 or 4 watts in it. Nice and smooth. That's working perfect as well. I don't know what happened, and I don't know what got soldered on this switch, but something is causing it to drag, and you've got to push and the jiggle pull, and it'll come right out. So I think if I glue this switch onto the post, which I really don't want to do, the customer can push and then jiggle and then slide it back out. This is the latest rendition of this switch. and there's no way to take this apart from the front. I'm going to ask the customer what he wants to do, because what the customer was explaining to me is that he just ran this thing with the variable all the way open and just ran it. Whatever it did, it did. And he didn't, I have the impression he doesn't care about this. So instead of me spending $200 or $300 of the guy's money to change the switch out, because it's so time consuming, change this switch is like a friggin' nightmare, okay? It's just a friggin' nightmare. Somebody changing that money around without asking him. You know, there is a resistor here that's missing, right? And this color Teflon wire is the same wire that's here, but like I said, I'm going to spend some time with it tonight. Needless to say, this thing runs titties on top of titties with like beautiful A-cup boobies that are magically bolted on, and now they're C's and they're tight. They're like fucking basketball tight or tennis ball tight. You know what I mean? Okay, so this thing's tits. I won't put the fan kit on it, but I really don't want to do that until I've been twiddly dicking with it. But still, the fan kit is set up beautiful for this. So this is the kit that comes from Beard. So we went ahead and we mounted the switch in the front. I am going to create a little fan on-off label that goes right up here, so you'll know up is on always. Zip tied all the way across, and then we've got it strain relief tied on the inside. It goes through a grommet. Of course, we're using actual Teflon wire, right? Got the grommet set up for here. Then we can run through, and then we'll run over to the power switch. So when you turn the amp off, the fan will shut off, or you can have the fan on and the have the amplifier on and the fan in standby mode. Which, if I'm not mistaken, that's exactly what you wanted. So I'm pretty sure I'm not mistaken, since we talked about it 3 times on the phone. Needless to say, that's ready to go in here, and all that is I solder here, and then I solder a wire here, and we're done. It's been a minute since I've been inside of one of these. We do not hook the fan kit up here, ever. Yes, this is a switch 12-volt source, but it comes from over here at the switch. If you hook your fan up here, this choke's going to catch on fire. And maybe even this choke, which then in turn will cost you these 2 transistors. So you see this pin here? That's where you want to hook up your fan kit. Not here. Ever. Never, say it with, never will I ever. So we have a on-off switch here that then in turn through a roundabout way comes over and turns the 12-volt on and off at the relay. Well, the relay switches 12 volts. It goes through this choke, goes on a trace and pops out over here, and this is what controls the bias circuit. All right. We don't add anything to this circuit ever. Ever. We don't do it. The reason I got to make a big deal out of this is I hope the guy that's watching on Facebook, the guy that made the comment on Facebook and was having problems with his fan kit, he couldn't understand why he hooked the positive wire up here and why this choke and that choke kept burning up, and eventually it cost him 2 pills. And we're like, yeah, because you tied on in the wrong spot. And he tried to argue with us and stuff. But I hope that he switched this around. I know that he kept burning this choke up. So, okay. I'm going to slap the fan kit on this, but first I got to sit down and take some notes. And I'm going to play with some capacitors and see what we can see, because up until this point, 890 watts has been the king on 15 volts. And we're on 15 volts flat, so it's probably doing this 1000 watt peak thing. Yeah, it's doing that on, what, 13 or 14.5 by the time it gets down inside the box, because there's so much loss from the connector to here. We lose usually about a half a volt. So 14.5, this thing's making 1000 watts with 120 watts of drive, peak. And I want to know why. Well, I know people that watch this video, and I know that there's going to be people out there like, oh man, it's all Harmonics. That's all Harmonics. That's, yeah, it's a spotter box. Yeah. Is it though? I'm gonna make you look like an idiot. Radio amplifier. Next order harmonic is 50 something dB down, 47 dB down from principal. Hello. Ain't splatter. And it ain't second and third and fourth order, whatever term you want to throw on it, ghost wattage. The principal's going up over +0, and the second order harmonic is staying below 45 dBm down, so, or 42 dB down. So it ain't harmonics, it's really making the power. And yes, it's all biased appropriately, right? It's not been modified for Class C or any of that. That's why I got to spend a little bit of time with it. I kind of wanted to trap people into that, because I know there's certain people that watch the video and they're, oh, it's splatter box. Nope. It's not what we do here. Not what happens here. So here's the suite. It's an earlier model. It doesn't have a number on the front. So this is a thermocouple activated fan, and this switch back here is for on-off. So you can shut the fan off, even though the thermocouple's kicked on and caused the fan to kick on. Already got strainer leaves. I'm not a big fan of how they did this here. It's technically very correct. Here's the problem: is this wire here is not soldered on. Right? The same thing here. Like, that just broke off the trace. Well, that one's actually soldered on. Okay, so 2 out of the 3 boards are actually soldered on. So the wire is big. This is true, and this will help promote carrying current to each one of the boards. I remember I used to build like this. The other thing is that this thing has been converted for Class C. If we look here, we'll see this ferrite's been shorted to ground. If we chase this trace over, it goes right back to ground. The extra inductor with ferrite on it has been moved to right here. Same thing is going on here, and that's not hooked up, and that just popped off the output tuning capacitor. Starting to see a theme here, aren't you? Same thing here. Now, this technically does help because we're doubling the amount of size of total wire surface area, but I propose that we take this power wire upgrade out, go through it and repair a bunch of stuff. The guy said that this amp was working, but then it slowly started to produce less and less and less power and less power. I don't see any burned up combiners, so this must have just barely been making enough contact to get 20 amps through this thing. But I mean, that solder joint is as cold as they ever could get, right there. That little shiny bit's all that was hooked up. So I propose that we just strip this down, start over. We're going to do a different power distribution, even though I admire this. The quality of the solder craftsmanship continues over here. This is barely soldered on here. See? Need a little bit hotter iron. As we can all clearly see, it was barely connected with this slobber right here on the bottom. There was, I mean, I popped that off one finger. Not a very good connection. So How about we abandon what we got going on here and let's just start over, and we'll treat this as, well, what it is. We're going to modify the fan. He wants to have a switch somewhere on the front that allows him to switch the fan on and off. He wants me to do away with this bullshit here, obviously. I mean, that's just so not right. It's not even funny. These caps have been really hot. They're not that famous for going bad, but we're going to lift one side. We'll check them all. We'll check this cap, because this cap slowly devaluating or losing its value of reference is usually what causes it to slowly lose power over time. But we'll see. Let's pull this out and we'll go from there. Okay, so we pulled all the power wires out, repaired all the solder traces that I think need to be repaired, and I'm sure a couple more are going to reveal themselves as I go through the cleaning process. And we modified it back, so now it's got full-blown sideband in it. I tested all the 1.8 ohm resistors. Yeah. Yeah. Been some weird stuff I found, but I wanted to show this here. The customer states, let's look at this last pin here. Focus, there we go. So this combiner attaches there, then attaches here, and then it attaches here. And we can see where that's been arcing for a long time. The customer states the relay sticks on this. Now what I am going to do is I'm probably going to pull the paddle relay out of there, and we're going to go to probably one of these 35 amperes that I've got over here that I can solder down. We'll switch that out here in just a minute, but I wanted to show the arc score and the arc burn so that it could just kind of sink into the guy that owns this, that just maybe it was causing, it would weld here, make contact, and then maybe it was welding the relay in place. There's two holes, I don't know how well you guys can see it, but there's two holes that have been drilled right there. So somebody could go in here and physically move the relay with a screwdriver. Well, we have the same problem going on over here, where somebody's drilled a hole so they could reach in here and mechanically move the relay around. So this here, these things wear out. These relays wear out. They've always worn out. They've always been a problem. Never been a big fan of them, but they work, right? We'll replace this. All this does is turn 12 volt on and off. Yeah, so we'll replace this, and I think the sticking relay issue is going to stop. Pretty sure. But I'm going to do this, and then I'm going to wash the whole thing and make it look all pretty and new and clean on here, in here. But that welding, that's pretty significant right there. That, I think every time that thing would arc, it was welding the relay and making it stick. Pretty sure. Pretty sure. Which tells me the connections on the inside of this relay are an abortion bastard anyhow. They're a joke, so might as well just go ahead and replace them. All right, moving on. All right, let's turn on the studio lights here. All right, so done. New relays installed. Pass-through tune adjustment is made. Power wire upgrade is installed and soldered in and tested. Checked all of our bias. Off to the races and running. Let's turn this off. So 1,000 watt slug and peak, and we're on like 12.2 volts. So hello, 1212, 80 watts in. Hello, 900 out. Turn this off. Go up here, let's take a look at our striker. Back this off just a hair. Boop, 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 there we go. So we're looking right here, and we're looking right there. Here's our pass-through tune, or otherwise known as the RF's ability to be able to go from the radio to the meter, down to the amplifier, into the dummy load. And we want to get this as low as possibly as we can, because we don't want it to mess with the receive at all. This is a 5 watt element in reverse if you've never watched one of my videos before. Hello, 111111111. Everything's happy. Input tune. Hello, 111111111. Perfect. In today's world, everybody thinks that this has to be perfectly flat. It does not. And as we noticed, as we modulated, the input schwurr dropped, right? Okay. Oh, shoot. The camera's blinking at me saying the battery's going to die. Hold on a second. All right. So, new battery is installed. Let's bring our operational voltage up to something that we'd see in the mobile. Get this up around 14, 15 volts. Hello, 1, 2. There's our 120 watts. Hello. Of course, it's off the scale. 2x. Hello. Hello. 1, 2, 1, 2. 1, 2. Beautiful. So good news, my man. You don't need any new transistors. This is a capacitor issue, a power wire issue, a relay issue, all fixed. I like going to this style of relay instead of just replacing. With this, these wear out and have a tendency to really drag. I don't care if you put oil in here, you polish them, clean the contacts, it never fixes the problem. This, on the other hand, has a spring. This is driven by a magnet, by the way. This is driven by a mechanical mechanism called a spring, not an electromechanical mechanism called a magnet. Although I have nothing against permanent magnets, I've just seen a lot of these fail, right? So let's use a mechanical reset mechanism, which is a spring. And then we get that ooh so gratifying ka-clink noise, which to some radio operators helps them have, well, special excitement abilities. I like big relays. I like things that go clunk, boom, and bang when I key down. Go dunk, dunk, dunk. That's just me. Hello. Hello, 1, 2. Yeah, this amp really wants to get with it. Look at this. Hello, 1, 2, 1, 2. It's almost making 1900 watts. That's with 120 watts of drive. So with his little modulator he's going to hit this thing with, it's going to really bug it down, get down, slap it down on the nipple. It's going to do it to it. Okay, let's put the fan kits on both of these and let's get these wrapped up, because I was technically supposed to have this in the mail today, and I got home from my road trip to California this last weekend, and I honestly did not want to dick with anything out here. Doesn't matter. Got to get this done. See, did I do everything I wanted to do while I was here? Yes. Fan kit on. Here we go. So, while on the phone with a customer, I went and I hooked up the fan kit. The Radio Shack Mono Y is broken, and only one of these leads is working. It's usually inside of this thing that we find the problem. So instead of dicking with it, I just said, okay, cool, I'm going to send you back your plugs. And I built him a new one out of Teflon wire that will never fail him. And it's made from metal bits and pieces instead of blow molded rubberized PVC plastic. Oh, whoa, the fans are not working. Why is that? There's a switch in the back. Remember we talked about this? Little micro switch. So when the amp is plugged in, you turn the amp on and it'll turn on. Or if you don't want to sit there and listen to your fans run all the time and you want to believe that the thermocouple inside this thing is going to do an adequate enough job to save your amplifier, you flip the switch down. When the switch is in the down position, the thermocouple will work. When the switch is in the up position, the fan turns on and it blows cool air and keeps your parts from dying. Amp number 1 completed. Let's go wrap up and put the fan kit on the Texas Star 500 and we'll be done with this thing. Before we go any further, I want to say thanks to the Patreons for allowing us to have almost this hour-long YouTube video with no ads. Big shout out to my guys on Patreon. Thank you guys. This is the hottest Texas Star 500 I've ever seen from the factory. I spent an entire day making notes on what I need to change on a test piece that I have over here, and I think I've managed to copy this amplifier's greatness. Give me a couple different ways to think about things. You never know when you're going to get inspiration or knowledge. You just got to be willing to see it when you see it. This is old Beard Amplifiers fan kit, which I absolutely love. I think it's great. Went ahead and put a label on it. Up is on, down is off. Just like I put a label on that. Put the crush nuts in it. Got the back all cleaned up nice and neat. So brother, I think, if I'm not mistaken, we're done. Now, if we listen really closely, the fan is in there turning. A little bit slow for my like, but I understand where Frank's going with this. I mean, very obvious, fan running. Come on, can't keep moving. Come on. Fan not running, right? Obvious, pretty obvious. I dig it though. This is working. This is by far right now the best fan kit in the market, in my opinion. The thickness of the case, the quality of the construction, the coating on the metal. This right now beats everything else that's in the market. So if you have never heard of Beard Amplifiers, you might want to check him out. He's building amps, but he's also primarily focusing on fan kits. I do feel that there's a couple other competitors in the field now that are coming along that there for a minute there could have been an exclusive monopoly if we could have gotten these made, but this is okay. I want the stock cabinets to get made. I want somebody out there to make them. I hope Frank is able to get that done for us, but we'll see. Time will tell. Well, gentlemen, I want to say thank you. Here's my number. Questions, comments, or anything I can do to help you out, any questions you got with your own equipment, don't hesitate to give me a call. Big shout out to Piglet. Big shout out to Penta, XS, Siglent, McMahon, Bird, Coaxial Dynamics. Remember, if you're ordering tubes from Penta, put BBI in the checkout and you get a 5% discount. Gentlemen, on that note, I say thanks to all of the Patreon supporters. I say thank you to all of you. Let's see, I think I'm going to go work on a messenger for a guy that he's going to give to his son for his birthday here. I'm going to get that banged out here real quick. I think that's next. RO's number 8384, 2023. We're in history. They're in the history done pile. And very quickly we're going to translate over to 2024 repairs. There's not a lot of them. I'm trying to set myself up so I can be ready to take on some new work here towards the end of this year in the next 3 or 4 months without having a year-long wait time. Appreciate you guys. I'll see you. Click, click.